if I wanted to be computer science, and I had other things like I could be a math major or I could be a physics major, but there was no concept of like computer engineering and or computer or cybersecurity engineering, which is really cool. So I think that that's one of the real awesome benefits besides the co-op program at UC, which is something that you get as a benefit of being a student here. So I was just saying that I think that we can draw a spectrum, we could draw a line. Uh, let's see, hold on, somebody just messaged me. Oh, good, thank you. We have a spectrum of majors. And I think that you have on one side this thing called computer science. And that is very much akin to the what I would call the theoretical idea of computing, what's possible, how do we organize things to do computing efficiently, how do we go about understanding the fundamentals and the foundations of what is possible with a computer. All the way on the other side of things, I think, is computer engineering. And with computer engineering, what I think you're going to get a lot more of with that is the circuits and the digital design. You're going to get down into more of the electronics of computing than you would at computer science. You are, however, going to get a lot of overlap. Like I said, all three of these programs have a significant amount of overlap. And then somewhere in the middle is this thing called cybersecurity engineering. And I don't know if it fits in the middle really well or not, because it's really a very not focused, but it does have this umbrella over it where you're really focusing on the security aspects. The reason I think it fits in the middle is because a lot of the core courses come from both sides. They come from the theoretical side, not only the theoretical side of computer science, but the theoretical side also of the mathematics of cybersecurity, which I think is going to be one of the more interesting courses that you're going to get to take in that major. It's one called the mathematics of cybersecurity. And I think that's really, that's going to be an excellent class. And then on the other side of that, you still, as a cybersecurity engineer, you still need to know a lot of the electronics that go into computer engineering as well. So I like to think of them on a spectrum. And what I've noticed about our curriculum is that the computer science and cybersecurity stay seemingly a little bit aligned longer than the computer engineering does. The computer engineering seems to take an almost immediate swerve into some of the digital design aspects, the circuits, the power, things like that. And so that's where I think that they do differ immediately, but then they reconverge again in the third and the fourth year. And then with your electives, they become stratified again. So if that makes sense, you kind of got this, like, they go this way, then they come back together, and then they can go this way again. So in that middle to upper tier, you do get back to being a lot of the same things. But as a computer engineer, you're going to have to learn what a Laplace transform is or a Fourier transform is. And as a computer science and a computer and cybersecurity engineer, you're not going to have to know that. That's not going to be a class you have to take. You're not going to take digital design as a CS or cybersecurity engineer, but you will as a computer engineer. The tier that I'm referring to up here that sort of comes back together are your classes like operating systems, your classes like discrete structures, things like that are all common. And then again, you go back and you can choose these stratified electives at the top. The electives are much more prescribed in the cybersecurity program than they are in the other two programs. The cybersecurity program has 3 distinct tracks that you can choose. And our electives then are chosen specially to give you the right bearing with respect to that. So if you want to do industrial cybersecurity with robotics and things like that, we have a track for that. And that will guide you in your choice of electives. So that is where I wanted to, honest to goodness, I was just telling everybody before you were all invited in, I want to hear questions and confusing elements of the difference between these three, and whether or not, and answer any questions you have about, hey, my interest is in this, should I do this or should I do this? My interest is in that, should I do this or should I do this? And I'll try to make sure that I give you enough options that you can always change your mind or redirect. I don't know what age you are, but I certainly didn't know what I wanted to be when I was a freshman. And so I know you're in a very difficult position, especially in the computing field at UC, because you've got these three choices that seem really very much the same. So with that, I will open it up to whoever is curious enough. And I know Hannah is a computer engineer, so she's very familiar, I think, with the courses that we have on the digital design side of things. I don't know what year you are and how far you've gotten into that. But I would love to hear a little bit of your experience about those courses. And because I have never experienced those courses. So that would be very fascinating to hear from you.
Yeah, can you guys hear me?
We can.
Awesome. So my name is Hannah. I'm a fourth year in computer engineering. And then I'm also in our Ascend program getting my master's in mechanical engineering.
Oh, wow.
As for courses, I'd say you're definitely right on when it's more in like the digital design aspect. I think computer engineering is super similar to electrical engineering with like a little bit more coding classes kind of woven in and a little bit more specialization in like computers. Is there anything in particular we need to talk about?
No, that's exactly right. I think that there is a lot of overlap. It's funny because I do think that there is a ton of overlap between electrical engineering and computer engineering. And that's always been like, my big fear is that somebody's going to come up to me and say, hey, you're a computer scientist. Can you do something with electricity and this circuit? And I'll say, nope, I cannot. I don't know anything about that. And so that's what I think is really neat, because you put it so well. Computer engineering is, that got that tinge of electrical engineering, but definitely applied. And I think you are in a very lucky position, because I know this from talking to other people who are computer engineering majors. You get to take one of my favorite courses of my entire career, which is computer architecture. And you get to take that course in your major, whereas in others, it's not necessarily required. But I think it's a fantastic course. So that's exactly what you're saying. It's that's a great example of a course where you can start very, very low and almost into the electronics of it, but it's always pointed back towards computing and applications in computing. So are you happy with the choice that you made? Do you feel like do you feel like you got down the right computing, the right computing track?
Yeah, I think I really enjoyed the classes that I've taken. I think when I was considering switching, it was mostly because I enjoyed programming, but once I started my courses, I realized that I really liked the electrical side of it, and I really loved all like the hands-on labs that we've gotten to do.
Very
so I
cool.
think in like the computer avenue, that was definitely the right path for me.
Good.
But I did realize that I like a lot more like hands-on electrical and mechanical testing, which is kind of why I added my master's in mechanical.
Very cool. Very cool. Yeah, I feel like, and also the only thing, the thing you're exactly right about is, if you are more interested in the software side of things, in writing applications, that's going to be more on the side of the computer science side of things than on the electrical engineering. And so if you're interested in software engineering, best practices for that, that's more of a computer science kind of thing. The good news is that if you really are like, look, I just don't know which one I want, the cybersecurity major really does offer this ability for you to sort of have a broad background of all these programs with the combination of the programming, the combination of the hardware. And then if you choose later, you can say, look, I still like security, but I want to do security, software security. We have a track for that. And if you want to do hardware security and satisfy your itch to get hands-on with some things, we have that track as well. So again, it's this opportunity to split between the two. So is anyone else, I know that one of the reasons that we're all here today is to, help make good decisions. Which way are people struggling with one choice that they made and they kind of think they want to maybe make another? Or are you just at the point now where you have to make a choice and you don't know where to turn?
Well, hi, I'm Andrew.
Hi.
Dr. Hawkins, I remember your talk about smashing the stack at an IEE meeting.
Yes. I thought
And
your name looked very familiar.
But that really sparked my interest for IT because I was currently in an IT course that semester as a first year freshman. And I'm in ENED 1 right now, so I still have a good amount of time to decide which track I want to take. But I'm also, I really like the aspect of coding and computer science. I have which that would tie into cybersecurity almost. But then I also have an interest for the engineering of computers, so actually building them and putting things together.
Yeah.
And I don't really know which path to take, and I still have a lot of time to decide, but I'm just kind of stuck between what I want to do because I was thinking about minoring in cybersecurity.
Yeah. And I think the cybersecurity could be used if you do minor in that. That could be used. You could use your electives in that to try to get over to some of the programming stuff if you really do find that you want to do the hands-on electrical engineering stuff, or the more electrical side of things. So, and if you want to, you could also do it the other way around. If you really wanted to, you could do a major in cybersecurity engineering and take the hardware track of that to get your, to talk about the cybersecurity of hardware and embedded devices and satisfy your itch that way as well. So that's just something to think about too. You could always do, another option is you could do CE, and then you could do a certificate in cybersecurity. You could do the same thing with CS and then a certificate in cybersecurity as well, if that's what you wanted to do. So that's a great, I think what's really cool about being in your position, and I was talking to some of the students the other day about this, was you get this, you're now in this opportunity where you can go take all of these classes and just learn so much again. I just wish I were back in your position again to be able to take some of these classes. So yeah. So, take your time, make sure you get a sense. And I think ENED is probably going to do a pretty good job of that with the physical demos and the physical work that you have to do with the robot and things like that, and LabVIEW, and to try to help you get a sense of, do I really like doing the physical stuff? And let that guide you a lot. So.
Yeah, I think I'm going to try to stick with computer science and then branch out from there somehow.
Yep.
But thank you for the recommendations.
Yeah, that's a great thing to do it. Yep. And I know Robin also has some really good perspective here. I've seen her smile knowingly a few times, and so if you have anything to offer, I would love to hear it. Thank you for being here.
Yeah, of course. Yeah, so I'm a third-year computer science student, and I'm also doing the cyber operations certificate, undergraduate certificate.
Nice.
Yeah. So I kind of had an interesting perspective where I came into college as a biomedical engineer with no programming background. So I chose.
You know Kelvin?
What was that?
Do you know Kelvin?
I don't think so.
Okay, he's a BME as well. He was in my class last semester, so I just.
Okay.
He's
Gotcha.
Sorry. Okay.
No, you're good. Yeah, so I chose computer science just because I didn't quite know what I wanted to do in the computing world. There was a lot of all of this unknown, just all of these unknown territories that I haven't yet had the chance to explore. So I chose computer science because I felt like I could dip my toe in all of these little, all of those little niches within the computing and technology world. And then after my information and security assurance class, I realized I really enjoyed working. I really started enjoying like information security, and that's when I chose to add on the cyber operations track.
Nice.
I currently co-op with L3 Harris and Northrop Grumman, so I'm already kind of in the defense, aerospace, cybersecurity world, but I'm hoping in the future I'll be gearing more towards just cybersecurity.
And I think you bring up a very good point. Thank you for saying that. I think you bring up a very good point. The reason that I like computer science is the same. It's one of the same things I was telling another student this morning, that you get the fundamental knowledge, the foundational knowledge of what's out there. You are going to be, as a computer science major, you're going to be set to be able to retool yourself over your career into using many different, weapons. And that's important because the field is advancing so quickly. You don't want to leave college knowing how to operate one particular compiler, one particular tool, one particular, section of operations, and get out in 5 years and find out, gee, I don't know enough to retool into another thing. And so you've made an excellent choice, I think, because you've got that background. And now if that tool or that path that you lead down, in 5 years, you think, man, I really don't want to do the cybersecurity thing anymore. Well, that's okay. You still have the computer science, you have the foundational knowledge, you can go back and you can rely on that and you can choose a different tack from there. So I think that's the power of the computer science major. Yep. Anyone else have any questions? Feel free to type if you'd rather type, and I know for some people that's easier. But just to give you a sense, this semester, I'm teaching a malware analysis course, which is part of the cybersecurity operations. It's in our cybersecurity engineering major. It's also on our tracks for our certificates. And that's a cross between a graduate course and an upper level undergraduate course. The course that I will teach over the summer is a programming languages course, just to give you a flavor for the kind of courses you're going to get in computer science. Programming languages is one of those courses that you have to take as a computer scientist. And it is a foundational course. It teaches you all of the different techniques and all the different paradigms for programming. You'll be exposed in all three of these majors to programming in object-oriented, procedural, and then in programming languages, we go a step further and we look at something called functional paradigms and logic programming. And the reason we do that is because it expands your ability to think about what's possible computationally and different ways to express it in code. And so that's the kind of thing that you're going to get as a computer science major. The difference, however, is that you're not going to get the interesting and deep dives that you would get as an engineer into how that actually translates into hardware. And that is just as fascinating and just as critical. You're just not going to get that in computer science. So that's the barrier there. That's the little horse you fall down on, and you kind of go to one side or the other. So that's my distinction there. Again, I know this is a really interesting and tough time because we do have all these opportunities for you. I just want to hear what you have to say, what you're asking about, what your interests are, and I can help. I can help guide you in one way or the other.
Hi, just a question. Sorry, we had a technical issue and we joined late, but
No problem. Welcome. Thanks for
thank you.
coming.
thank you. My daughter Sydney is interested in computer application development.
Mhm.
So would that be more in the engineering side or would that be in the computer science side?
I think that would be more on the computer science side of things. I think that would be more on the computer science side of things. Hannah, I would like to ask your perspective on that just from the counterfactual side, but I think that's computer science. And the reason I say that is because in the computer science side of things, you're going to get a lot of exposure to not only the different languages that you might use to write these applications, but you're also going to get exposure to the algorithms that you're going to use from a theoretical perspective. And you're also going to get a introduction to the sort of encompassing technologies, like how do teams work to actually do software engineering at scale? What tools do they use to interact? Some of what I like to think of maybe is, not it's quasi organizational psychology. And I think that that's a really powerful thing to have as you graduate. And I'm not 100% convinced that if that's what you want to do, the engineering side of things is going to be very valuable to you. Hannah, do you agree with that, or?
Yeah, I agree. You could definitely go that route with computer engineering, but you're not going to get as many classes on that unless you take like electives within that field.
Yeah. And I think one of the really interesting courses you get as a computer science major is the one of the artificial intelligence courses, where you're going to get exposure to not just classical AI, but also the machine learning. You're going to get to learn a lot of the tools of the trade for doing the sort of new computer science stuff, which is machine learning, classical AI, data science, and you're going to come out being able to do all of those different things. So if you want to go the route of writing software applications, you can do not only just the what I like to call having someone just tell you, hey, I need an app that does this. You can say, gee, here's all this data. I know what I want to do with it. And I actually have the knowledge to not only have somebody else tell me the ideas, but to have them myself. Like, oh, I can run this data analysis algorithm on it and get this thing out of it. And I think that's really neat. So that's one of the benefits you get from going down that CS track.
Great. Are we on mute or are we good?
Oh, hold on, you flip back over. Yeah, there you go. Sorry.
Sorry. Just a follow-up question to that.
Yeah.
So we're going to purchase a MacBook for graduation for her to have with. So obviously going into, software engineering, what type of Mac does she need? A MacBook Pro? Does she need to have, terabyte memory,
Yeah, so that's a good question. So that's an excellent question. So I know that they have come out with their new M1 processors,
right,
which are awesome. And Corinne just put our recommendations on there. That said, I think that, look, I'm a geek. So if you can say, hey, this one goes faster than the other one, I'm going to get it. But having said that, the M1 processor in the MacBook, the new one, or I think it's the M2 now, whatever it is, it screams. And it's amazing. I have one. I bought it the week it came out because that's how badly I wanted it. They scream. They're low battery. They're amazing. The only downside to that is that there are they right now operate on such a different architecture from Windows laptops and just from a hardware perspective that there's still that transition. For me, I'm teaching computer science 1 right now with freshmen. I make, when we have labs, I make starter kits for Windows and Mac, so it's not a problem. I do that for my other second class. We actually are working in a virtual machine right now, so the students can learn Linux, so that the underlying hardware doesn't matter there. We just sort of operate a level. But yes, the students I see, and I think Hannah and Robin can maybe say something about this too. The students I see have Windows, Mac, a wide variety, doesn't matter. But, I think, again, if you're buying an investment, obviously it seems like just get as much as you can up front. Right. Unfortunately, it's like a car. It's going to be, bad as soon as you buy it. But the bigger you can go, the better. I think that'll help you in the long run. Yep. Great question. Does anybody, Hannah or Robin, did you have just a statement about that or anything? What have you seen from your peers?
Yeah, so I know for I have a PC and also a Mac. And I carry my PC is huge, so I just kind of like go to classes with my MacBook because it's a lot easier to transport. But for my database class, we are using Microsoft SQL, and
Interesting.
my
Interesting.
professor, he gave us download instructions for both Mac and Windows, but he only goes through like Windows examples. And I think that's kind of a common thing, that like professors will give you the resources for either operating system, but a lot of times they'll traditionally only go with the Windows, because I think a majority of the students have Windows computers that have Windows operating systems. So you can use Mac, but I know that those students often have to jump through some more hurdles. But
So-
just from my perspective.
No,
Yeah,
no,
no,
that's great. So,
Yeah,
so
that's a great perspective. And I try very hard not to discount one platform for the other, because it is much more of a split than it used to be. But it's hard because if I don't want any student to just sort of be sitting in class going, why isn't he talking about something that matters to me? And if everybody's 50-50, it's like, I don't know, like, who do I discount today? So, I think everybody's going to try very hard to make sure you're accommodated.
okay. Yeah, I wasn't sure if she had, let's say, a MacBook Pro, could she also work off like a Microsoft Surface for
Yeah.
any applications that would need to be Windows based versus,
Yeah.
Mac?
Yeah, that's actually, I carry 2 laptops, if not 3, and I have a Surface. I'm talking to you on a Surface right now
Okay.
for Windows stuff, and they're great. The new Surface is really great too. But yeah, and I think the benefit is, you can always run a virtual machine on a Mac that will run a Windows operating system. It's sometimes not, but if push comes to shove. So,
Okay.
yeah.
And I'm assuming that there's computer labs that also have access to.
Oh, yes, 100%, 100%. Yes, and I think that's I'm sorry, I forgot to mention that the lab that I teach right now has the students mostly write the labs on their laptops, but everyone has a seat at a computer during lab time that they can use that has all the software on it already. Yep. And they are great. The labs are they're physically very nice, and the computers there are very nice. So you would not be in any sort of disadvantage if you wrote your code on those.
Great.
Yeah. I don't want to put anybody else on the spot, but I see some black boxes. And so if you have any questions, please feel free to unmute and ask away. So that's why I'm here. And there are some great resources in the chat as well that'll give you an overview of our computer labs, and then also the specs, which I actually haven't looked at the specs yet. I'd be very interested in seeing what those are for next year. So, yeah.
So I'm planning on continuing on the computer science track, and so I know you talked about a class you were going to teach. You're teaching it right now in the spring. Cybersecurity. I forget the exact name. But I was
Malware
wondering-
analysis.
I was wondering when you would be offering that again.
That's a good question. I think that one's offered. I'm going to look in Catalyst right now. That should be offered every spring. I believe we're offering that every spring. Let me just check in Catalyst to make sure. It's 5138 is the undergrad number, if that matters to you at all. But I'm looking right now. I was having the hardest time getting on Catalyst for some reason. Browse course catalog, that's what I want. Science. There it is. All right, 5138. Where are you? Well, that's interesting. They said it's offered occasionally, but I know that I think, okay, I think now that we've added that major, the cybersecurity engineering major, we're going to be, I believe we'll be offering this more often.
Okay.
Yeah. Yeah.
I'll look for it when I'm scheduling classes then.
Yeah, please do. I don't think it will be again in the spring, or I'm sorry, again in the fall. I think it'll probably be next spring.
Okay.
There's a related one though you can always look at. It's reverse engineering, and that will be very similar in content.
Okay. I'll take a look when I'm scheduling.
Yeah, yeah. Get back to my, oh, I can see you again. Good. These are great questions. These are great questions. So if somebody, I will do this. How about this? Anybody want to give a thumbs up if they're starting next fall? Who here is starting next fall? I know Sydney said she is, so I got that. But is anybody else on the call starting in the fall? That's an unfortunate rhyme, but okay, good. Wesley's in the fall. Okay, cool, very cool. Well, we're glad to have you in the in one of our three majors, no matter which one it is. So yeah, we'll. I think that the first year is a very interesting major. It's a very interesting set of courses, and I think you'll like them a lot. I think it exposes you to a lot of the different things that you're going to be doing, and it gets you working with your peers and teaches you a lot about how to work together with others, and which is really important, not only in the computer science majors, but just in general. And yeah, so I think you'll really enjoy it. I think Bernard joined us a little bit late, so that was welcome to Bernard. If you have any questions, please let me know. We're just chatting. Is there anything you wanted me to cover, Corinne, that I didn't talk about explicitly?
I mean, this has just been absolutely wonderful so far. I'm
Oh
learning.
my.
I'm learning so much. The thing I always want to ask about and hear about is
Yeah.
co-op.
Yeah.
So kind of like, are the company students going to the same? Are there some only hiring one major versus the other? What is
That's a
it
great
like?
question.
Yeah,
Yeah.
And can you get experience in both, I guess, through co-op,
Yep.
regardless
Very
of
good.
which one you're in?
Yep, that's a very good question. I think, and I do want to ask Hannah about this because I think it's interesting. I don't know what a computer engineering co-op looks like different, like how it's actually different than it would be for a computer science or cybersecurity engineering. I know what those look like. I know what the computer science and the cybersecurity engineering look like. The computer science is going to get you a lot of exposure to doing actual software engineering. Right now, one of the people that I'm working with as an undergrad in research is at Northrop Grumman, or I'm sorry, it's at Siemens, and they do like large scale software engineering. They have a big CAD product that they work on, and the students are always very involved in that, doing a lot of updates, and that's real software engineering stuff. That's real computer science, software architecture, and things like that. Our cybersecurity engineers are going to do a lot like what Robin was talking about, where she's going to be at one of the defense contractors, probably Northrop Grumman, and they're going to be doing things that are, you can't talk about. But they're going to be analyzing. They're going to be looking at defense in depth. They're going to be looking at how to defend those systems. And I just don't know how that looks for a computer engineer. Is it, are you doing more of the synthesis? Like, are you writing VLSI or VHDL all day? Are you actually helping them fab things out? Hannah, if you could give me a sense, that would be fantastic.
Yeah, I think it kind of depends on the company and the job that you go for, but I will say that there's like a very broad spectrum of opportunities. Speaking from personal experience, my last 2 co-ops were with Stress Engineering Services. And I was technically an electrical co-op, but I was mainly working on this electronic prototype that I can't talk much about because it was for another company, but I was able to help with kind of writing the firmware for the prototype, and then also doing some more like electrical testing, looking into more electrical pieces. So I found that I was more interested in the electrical side, so I kind of steered more toward doing a lot of like hands-on electrical testing and looking into those components and stuff. But I definitely had the opportunity to help with more like firmware type things. And my first co-op was a lot more computer science side. I was helping develop a online platform to analyze electronic health records. So I was helping with like the development of a website and stuff.
Very
and then
cool.
this summer I'll be going to P&G and be doing more mechanical stuff in their plant in St. Louis.
Very cool. Yeah, and I think Hannah used a good term there that I think really applies very, very well to the computer engineering side of things, and that's firmware. And I think as a computer engineer, you're going to be very well suited to do a lot of the firmware engineering that some of these companies are doing. You know, it's almost impossible now to buy something without a chip in it. And so what you need in a lot of those cases is you need some blood-brain barrier between what the software can do to actually control the hardware that it's embedded in. So no longer is the software limited to the microwave where I can set a timer. It's the microwave that hooks up to the Wi-Fi. Well, that's fine and good, but now I need somebody who speaks enough software to be able to write the software that can connect to the Wi-Fi network, accept commands from the internet. But then also, I need someone who is talented enough like Hannah to turn around and also write the code that can talk to the hardware. That actually, hey, fire up the thermostat, or, this user wants the turntable on in the microwave, not the, this, and that's where having that ands, ors, and not gate sort of knowledge comes into play, because I know how to do that. So that's I think is a benefit to doing that as well. And also going back to our conversation, 40 minutes ago about Laplace transforms and things like that. Hannah, you're going to need to know that, because now I need to know, hey, the user wants the temperature at 70 degrees. Well, I need to look at the series of, how do I write a digital controller that slowly gets me down into that without burning out the thermostat on either side, or the user wants this T to be 180 degrees, not 170, and I got to get to that as well. So there's that's where that math comes in. So I didn't, Robin, you were shaking your head again knowingly. I wanted to make sure that I didn't leave you out there. It looked like you might have had something you wanted to offer.
Oh yeah, so I think like everything that you said about computer science co-ops was pretty much like on par. Where I co-opt, I was actually working with embedded systems, so I was definitely more on I was kind of verging on the computer engineering side with a lot of the projects I was working on. Like, in the software department, I was like the black sheep because I was the CS student and not the computer engineer. But I think you're still able to do a lot of more standard programming. Like I was using PyTest and creating a testing framework, a regression testing framework for products, and we were shifting them around to programs. But that was my second semester. And then the first semester, I was doing software hardware integration and kind of getting down to that lower level. So when you're looking at co-ops, you're going to be able to say, oh, you're in software engineering. Well, there's so much that you can even do within a single job in a single position.
And I think that's what's really interesting about the co-op. I think, and especially that's where I learned. I didn't have a formal co-op opportunity, again, small school, but my internships, I think that's where you really get to learn. Because let's say, for instance, Robin is a CS major, and you go to your co-op, and somebody at the co-op says, hey, guess what? We need you to do this. Or okay, what are you going to do? I got to crack open Google and figure it out. And that's the kind of learning, but you can do that because you have the fundamental knowledge in the background. And so you can take these opportunities at the co-op to say, wow, that's really fascinating. I'm a CS major, but I really do like that little bit of electrical. So let me see if I can, hey, do you have a job I can do for that? Or, hey, that project looks neat. And then in Hannah's case, she can go the other way if she wants to. She can say, that's pretty cool. Maybe I want to write some software here for this thing. And so I think that's the benefit. I don't need to convince you all that the benefit of the co-op, because you're already, it's like the choir here. I'm already preaching to the choir, but that's the benefit of the co-op, is that you really get to extend your knowledge and tailor your experience at the co-op to learn what you want. So, and that's what you bring back. And we had some new people join us, so welcome. I lost track of who came recently, but welcome. And we're just talking about the differences between cybersecurity, the cybersecurity engineering major, the computer science major, and the computer engineering major. And I'm under very, very, very strict orders from my department chair to talk up talk about cybersecurity engineering as much as possible. So he's not listening on the call, but I'm sure he's found a way to hack into this Zoom call and make sure I'm properly giving it the props that it deserves. So another one of the cool opportunities I think we have too is as I think second year, maybe even, but definitely as a third and fourth year, you can apply to be a TA as well in some of these courses. And I think that's another fantastic opportunity. One of the things that I've realized as a professor is that you don't know it until someone asks a question of you completely out of context and you have to explain something to them. You're in a course about C++ and a student comes up to you after class and says, hey, in Python, how do you do that? Oh, I don't know. But you get that experience as a TA. And so that's another bit of experience you can get. So, Robin as a CS major could TA for, if she wanted to, she could TA for CS1 with me. She could TA for CS2 with me. See what I'm going with here? I need a good TA. She could TA malware analysis with me. But any of those CS courses she would be, and that would give her another opportunity to learn as well, and to grow her skills. And I'm sure the same thing is true with Hannah. I'm sure you've had similar experiences, either working with TAs or being a TA. But in those fields, you would sort of do the what's the first? It's a digital design with Dr. Joe Wenben. I don't know if you had him, but he's the one who I've sat in with his class for digital design, so I know that's one of the early ones. But
yeah, I had him for digital design.
Yeah. If no one else has any questions, I have a question for Hannah, because I've always been fascinated about this. So I'm a huge network analysis person, but I think of it as being analysis of graphs and things like that, networks of like interconnected units. And I know network analysis in electrical engineering has a very particular thing, a very particular meaning. So when you take that network analysis course, what do you get out of it?
It was my second year, so I'm thinking back a while now. But it was mostly analyzing different forms of circuits. So we'd have like an electrical circuit, and we kind of learned about the different ways to figure out the voltage through one loop or the current.
Got it.
It was a lot of like different types of electrical setups, and there's a lot of math involving that.
Great. That makes perfect sense. That helps. Thank you. We had a great question come in. I know that cybersecurity engineering is a relatively new major at UC, added last year. How good would you say the program is compared to computer science and computer engineering? That's a very good question. I think it's an excellent program. I think what's interesting, that's right. So I think what's interesting about it is that not only are you going to get a lot of the classes that we've been tailoring or that we've been fine-tuning over the years at the first and second year levels, you're also getting the development of cutting edge upper level courses as well. So I think that you're going to get, especially this math for cybersecurity course that I was talking about earlier, is a brand new course. We're designing it from scratch. And as the benefit of that is that you're going to get the immediate, the most up-to-date content in that curriculum. You're not going to rely on someone updating curriculum or their ability to update that curriculum. It's going to be the best. And I also think that the benefit, one of the other benefits of the cybersecurity engineering major is the fact that we have those very well laid out elective tracks. And I think that can help guide you into what you want. And that is a differentiator with the other majors, where there's not as much maybe feedback or help from your advisor to say, oh, you really are interested in this? Oh, well, maybe take this elective. We say, okay, what major, what subfield of cybersecurity do you want? We've already thought about the good courses for you to take in that. So I don't think there's anything, I guess I'll put it this way. There's nothing about the fact that it's new that should discourage you. In fact, I would almost argue quite the opposite. That the newness and the freshness of it is leading to big expansion. We're thinking about even expanding it further. And so the expansion and the newness is something that is a good selling point, I think. I hope that answers your question.
So actually, I have a question about the cybersecurity major. So I know for cyber operations, it's a part of the, the National Centers for Academic Excellence. And my understanding is that UC is partnered with the NSA, and the NSA helps influence and tailor the course to like needs for national defense and just kind of offer their influence and expertise. So is the cybersecurity engineering major also take influence from that?
Yes, that's a very good question. I say yes, not knowing 100% that that's officially true. I know that the operations certificate definitely does. Like by the letter, it is not sanctioned, but they work with that. Having said that, there's no way that relationship is not going to help us with this major. I know that we are just applying right now to do another re-up of that relationship with the NSA. We're submitting all of our paperwork for that now. So yes, absolutely, that relationship is going to continue. Yeah, and it's a very vital part of the two. And in fact, also what Dr. Kahay is doing is also getting us very involved, or building a very active industrial advisory board for the cybersecurity major as well, which will be independent of the other industrial advisory boards we have for the other majors, so that we know, for instance, we met with somebody from Fifth Third the other day, and they said, hey, we really need this in your majors. This is what we're trying to find. We need people with these skills. And that's the kind of feedback we're getting from people, so that we make sure that the coursework that we're offering and the skills that we're building are the ones that they need. So yes, it's definitely the NSA, but it's also other people who are making use of our graduates, or soon to be graduates, I guess. So yeah, that's a great question. Are you taking a cyber course this fall, right now, Robin?
I'm not. I took
Okay.
last summer, I took Introduction to Cyber Defense. It was a policy course. So it talked more about, was that
with Dr.
Sorry, my computer is blowing
right.
up.
Was that with Dr. Hartnett?
No, it was with, she was a PhD candidate. And I forget her name. It was all asynchronous.
Yeah.
But, it was really cool. We talked about all of the different nation states, the history of how cyber war start, or how even just war in general, international conflict started, and then how the introduction of technology has kind of shifted that landscape, and more geared towards cyber warfare.
Very cool. Yeah. Dr. Hartnett is teaching a class right now that's very similar to that, where they're doing a wargaming scenario where they've got people modeling attacks and sort of tabletop gaming out their responses and things like that. He is an expert in it. And I think that's what's really cool about our our college is how active we already are in cybersecurity engineering even before we had the major. I know we're talking a lot about cybersecurity engineering, and I'm only doing that because there seems to be genuine interest. But yeah, we are. We work with a lot of the statewide groups, but also Dr. Harknett has connections to at the national level as well. So yeah. Well, I know we're sort of winding down, and everybody's had a long day, but feel free for anyone on the call to send me an email if they have any questions or need anything at all. I'm happy to answer any questions that you all have. I'm in the research directory in the global address book for all of you who are maybe not on campus yet. But feel free to find me. Find me when you get to campus. Find me before you get to campus. Whatever you need, I'm always around to help. So.
Awesome. Well, thank you so much. And thank you, Hannah and Robin. Your
Yeah.
experience was just so awesome to have as part of this conversation today. We will put the email addresses in the chat box, and you can see Alex provided
Oh, I'll
contact
put mine
info.
in right now. Sorry, I didn't realize I could do that.
Okay, perfect. So if you do have any follow-up questions, we do encourage you to reach out to us. We love helping you figure out where the best place for you to be is. All right, everyone have a great day. Thank you. We'll see you next time.
Yeah,
Thank you
thanks.
so much.
Thanks,
Appreciate
everybody.
it. Thank you.